Here we're going to take a look at a simple model of water evaporation, and this will be what you'll use for the evaporation activity a little bit later on. You'll go to the URL up here, which is included on our website and in the evaporation activity, in case you can't read it on here, and scroll down here to this environment here, and then we'll click on Start just to see what's going on. Here, the dark blue dots are supposed to be liquid molecules, and the light blue are vapor, water vapor, which would be invisible to us. Let me click the Start button again so it starts completely over. The idea here is right at the start, all of the water is in the liquid state, and this area up here is completely evacuated. What happens is that water molecules begin to evaporate and fill this space. As they fill this space up here, the pressure increases. That is, if you had a pressure gauge connected to here, you would see the pressure gradually go up from 0 to start with up to some value, maybe 20 millibars. Remember, normal sea level pressure is roughly about 1,000 millibars. Now, regardless of whether there are air molecules here or if it's completely evacuated, the number of water molecules that are going to evaporate into this space will be the same. The number reaches a saturation level or an equilibrium level when the rate at which the evaporation from the liquid to the vapor state matches or equals the rate at which water condenses back into the liquid state. Let me go ahead and start that again. When the evaporation rate and condensation rate are equal, the number of water molecules in this space remains constant, or the water vapor pressure remains constant. Again, a normal vapor pressure for our atmosphere might be about 20 millibars on a fairly warm day with quite a bit of water vapor. 20 millibars would be 2% of 1,000 millibars. Normal sea level pressure, again, is 1,000 millibars. So 20 millibars would represent that 2% of the water molecules are water vapor. If it were 30 millibars, then 3% of the air molecules would be water vapor. Okay, good.